Now, welcome to my channel, STEM Cafe. Where we make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, and entertaining. We have treated circle theorems before, and we have done some circle problems. But these are from GCSE exams. So we are trying to solve it, and the most important thing is, no matter what the circle problem is, go to the basics, the theorems given to you. And with those ones, you can solve almost every circle problem. Now, let's face this one. A, B, and C are points on the circumference of a circle, center O. DAE is the tangent to the circle at A. Angle BAE is 56. Work out angle CAO. This angle. This is where you want us to find X. Now, we can start by looking at this. The angle here is 90 degrees. The angle from between the radius and the tangent is 90 degrees. So this is 90 degrees. And we have this place at 56. So what will this place be? It is going to be 90 minus 56. So this place will be 90 minus 56. I think that will be 34. So this place is 34 now. And you can see this is radius, this is radius. So automatically this place will be 34. Now, we know something about angle in the alternate segments. Angle in the alternate segments is equal to the angle between the radius, is equal to the angle between the tangents and the line joining the tangents. So which means that this place will be equal to this angle here. So we have this place will be 56 degrees. So you can see we have gotten almost all the angles. And you know angle in a triangle is equal to 180 degrees. So with that we can find angle CAO. And we have triangle C in triangle CAB. We have 56 degrees plus x plus 34 plus 35 plus 34 is equal to 180 degrees. You see, this is the triangle here. So this one here and this one here plus this one gives us 180 degrees. So we have 56 degrees plus 69 plus x plus 34 degrees is equal to 180 degrees. Now, so x will be equal to 180 minus, you know, this one and this one is 90 degrees, plus this one is 159 degrees. So we have this one as 121 degrees. So you see, it's very simple. So you can see, it's very simple. We were given this angle initially and this one. So from there, we were able to solve everything. We have another one. A, B, and C are points on the circle of radius 5 centimeters. A, B, C. DA and DC are tangents to the circle. DO is 9 centimeters. This is 9 centimeters. Calculate the length of arc ABC. Here now, very simple. We know that the angle between this place and this place is 90 degrees. The angle here is 90 degrees. So we have congruent triangles AOC and DAO and DCO. Simple. So with this, we can find the angle here and we can find the angle here. So you can see that they are congruent, and then which means that this angle here and this one will be equal. So alpha, yes. So this place and this place will be equal. Yes, alpha. So let's just find one alpha. So if you look at this, we know this side, we know this side. So this is the hypotenuse, this is the adjacent now. This is the hypotenuse, this is the adjacent. So we can say that 5 all over 9 is equal to cos alpha. So alpha is equal to r cos 5 over 9. So this angle here is 56.25. So the total angle here is equal to 2 alpha. So angle AOC this side, that will be obtuse. Because we need the reflex angle to be able to find this arc length. Is equal to 2 times 56.25, which will be equal to 112.50 degrees. So the angle side we need is this place. So angle AOC reflex. That is the angle we need. Will be equal to 360 minus 112.50, and that is 247.5 degrees. Therefore, length of arc ABC is equal to 247.5 360 times 2 pi 5, and that is 21.6 centimeters. Here we have A and B are points on the circumference of a circle, center O. So this is A and B. BC is a straight. BC is a tangent to the circle. AOC is a straight line. This one. Angle ABO is equal to 40 degrees. Find the size of ACB. Angle ACB. Angle ACB. So this is what they want us to find. They have given us that this one ABO is 40 degrees. We have been given that. Sometimes in the exam they might assign alphabets, but I am putting figures for clarity. Here, we know that this place is radius, so this place will be radius. And because we have isosceles triangle, the base angles will be equal. So this place will be 40 degrees. And we know that the angle between the tangent and the radius will be 90 degrees. So we can see that this is 90. We can have triangle ABC, or you can find this place and then find x. Either way. But if you find this place will be the sum of this one and this one. This will be, you understand? The angle, the exterior angle is equal to the sum of the opposite angles. So you can either say, okay, triangle ABC, and then find this angle here, add it to this one, and this one is going to give you 180 degrees. It's going to give you 180 degrees. So let's see. Or if you find this angle here, we find this one here. Now let's see. Triangle ABC. We have this place to be 130 degrees. That is 40 plus 90. This place is 10. It's 40. So x plus 40 degrees plus 130 degrees is equal to 180 degrees. So x will be equal to 180 minus 170 degrees. So which is 10 degrees. And like I said, you can consider triangle BOC. So if you want to do that, you just need to find this angle here. And this one, by the time you look at it, you might find this one, then subtract from 180, but at the end of the day, this place will be 80 degrees. So we are going to have triangle BOC, and that's going to be 90 degrees plus 80 degrees plus x is equal to 180. So x will be equal to 180 minus 170, which is 10 degrees. So you can see, very simple. A, B, C, and D are points on the circumference of a circle, center O. This is A, B, C, and D, center O. FD is a tangent to the circle. We have to find y. There is a relationship between y and this place, so I deliberately gave it a figure, so for ease and clarity. Now, we know one thing. This place and this place will be equal to 180 degrees. So this place is equal to 180 minus y. 180 degrees minus y. You have already settled that one. Now, I draw another line from the center to the circumference. So, we are going to have isosceles triangle here, and this place will be 25 degrees. That one is already gotten. We also know one thing. Probably you might not need it, but then before I go on, 25 plus 25 is 150, is 50 degrees. So if you give this place to be 180 minus 50 degrees, and this place will be 130 degrees. 25, 25, 130 degrees. And one thing is sure, 130 degrees and this place, this 130 degrees is going to be double of this place. Double of this place. So, how did we get this 130 degrees? We subtracted 25 twice from 180 degrees. So we are going to get this place now. So this place is going to be, so we have 180 minus y is equal to 130 divided by 2. You remember that theorem that says this one will be double of the one on the circumference. So it's going to be 65 degrees. So y will be equal to 180 degrees minus 65 degrees, and that is 115 degrees. So, assuming this place is given to us as x, now let's see. So, since we have this place as x, this place will be x. So, this place is going to be 180 minus 2x. So, at the end of the day, 180 minus 2x, this place will be half of 180 minus 2x. So, we are going to have 180 minus y will be equal to 180 degrees minus 2x over 2. So, what does that give? 180 minus y will be equal to 90 minus x. So, the relationship between y and x. So, let's bring 90 here. So, we are going to have y to be equal to 180 minus 90 degrees plus x. So, you can have the y minus x is equal to 90 degrees. So y minus x, you can see, and by the time you check it, 115 minus 25 that was there before, what did we get? That one will be 90 degrees. So this is another way of looking at it. So, very easy and straightforward. Now look at this. We have circle A, B, C. And tangents to the circle F, C, G, and D, A, E. And we also have angle X here, angle Y here, and angle A here. We are now asked to find angle A. We are asked to find this angle A. To start with, we can go straight and get this. That A to this place is 90 degrees. That is the radius to the tangent here is 90 degrees. That one is gone. Now, we know from alternate angle perspective, angle in alternate segment, sorry, that y and this place will be equal. This place is equal to, this place should be equal to this. This place should be equal to this. Now we have another one there. If you look at this place, this will be 90 minus x, angle B, C, G. This place is 90 minus A, sorry. If you look at this place, it's 90 minus A, because from here to here is 90 degrees, and this place is A. So from here to here will be 90 minus A. I hope you understand. This place to this place is 90. So this is A. So the remaining angle will be 90 minus A. Now, with this, you can see that this place is 90 minus A. Now, let's add all the angles in triangle ABC. Angles in triangle ABC. Triangle ABC. We have 90 minus A plus Y plus X is equal to 180 degrees. So, we can now say that A plus Y plus X, sorry, we can now say that Y plus X minus A is equal to 180 degrees minus 90 degrees, which is 90 degrees. So from here, so we can now say that A will be equal to Y plus X minus 90 degrees. From here. Let me just put it like this for ease. So we can now see that y plus x minus a equals 90 degrees. Now, let me add a to both sides. So y plus x is equal to 90 plus a. So y plus x minus 90 is equal to 8. So the same way you can say x plus y minus 90 degrees is equal to 8. So the major thing we use here is angle in alternate segments. So this one equals this one equals this one equals this. Now let's quickly do this one. Now let's quickly handle this. A, B, R, and P. A, B, R, and P are 4 points on a circle with center O. So this is the center for this circle. This is the center. Now, A, O, R, and C are 4 points on a different circle. So this is a different circle. These are A, O, R, C, which means that this circle passes through the center of this other circle. The two circles intersect at the points A and R. Intersect here, intersect here. Prove that angle CAB is equal to angle ABC. CAB here, let's call this place X. They are telling us that it's equal to angle ABC. So let's call this place Y. So we have to prove that angle X equals to angle Y. Now, since this place is the center for this circle here, we can see that this place is the radius. You can see. So this one too here will be the radius. But this point, and this point, they are on this other circle here. So, and if you look at it, we have a cyclic quadrilateral here now. So, A, O, R, C is cyclic quadrilateral. And in cyclic quadrilateral, opposite angles are supplementary. And what does that imply? It means that this angle here plus this angle here will be equal to 180 degrees. So it means that this one and this one here is equal to 180 degrees. So it implies that this place is equal to 180 minus x. And if this place is 180 minus x, it implies that this place too will be equal to x. Because the total angle here will be 180. So it means that angle ORB is equal to x. And now look at it. From O to B is a radius as well. OB is a radius. You can see AO is equal to OR is equal to OB. They are all radar. Now we have discovered that angle ORB is equal to x, because this one and this one must be equal to 180 degrees. So automatically this one is equal to x. Or even by the time you look at it in cyclic quadrilateral, the external angle is equal to the opposite angle. So x and this one are equal. Now see this place, this is radius, this is radius. What does that imply? It means that triangle ORB is isosceles. Therefore, x is equal to y. So if in case you come across something like this in the examination, you should be able to, write the theories or theorems rather you are referring to, where you are stating your facts. And I believe that the way I have shown this is interesting and has enhanced our understanding. Nothing outside the theorems, nothing. And with this, you can see how simple it is to handle circle theorems in any examination or application. Thank you very much. Please share, subscribe, comment, like, and you can check us on other channels too. Thank you very much for your support, and if you have anything, suggestion, all these are welcome. Thank you so much.